Yeah, good afternoon. So, in the last lecture, we have started the examples based on the design of Purlin, and I think we have covered how many steps we have covered in the
6.
class? 6 steps. Okay, so design of Purlin, and we will go with the step number 7. So, design of Purlin. So, step number 7. So what was the step number 6? I think calculate the factored load due to combination. That was,
Yes, sir.
Okay. So now next step is a calculate. Step number 7 is a calculate biaxial movements, correct? Calculate biaxial movements. So mx and my we have to calculate. So mx is equal to wx into L square by 10. So W is this formula is correct? Please see the formula.
Yes, sir.
Just a minute. Wait. I think just a minute. Okay. So now, what is Wx? How much value of Wx?
747.48.
747.48 into L square. L is the what? We have written. L is the spacing of truss we have written. So how much spacing of truss?
4.
Spacing of truss is 4 meter. 4 square divided by 10. So calculate mx in Newton meter.
One 1,195.93.
1195.93. Okay, so this is the your movement in x direction. So the second is the my. So my is again wy into L square by 10. So wy, how much wy? Maximum intensity of pressure or maximum wind speed, sorry, maximum load out of x and y direction we have taken. So what is the wy? How much value?
Minus 2059.96.
2059.96.
96.
Actually, the हे जी minus value ती कशासाठी आपण करतो अपलिट प्रेशर. So here we will not write, but we will consider this sign. So 2059.96 into 4 square divided by 10. So this will be the maximum biaxial bending moment in the y direction. So how much this value?
3295.93.
3295.93. Okay, so these are the biaxial moments. Got it? So now we will go move towards the next step, that is the step number 8. So these are the two mx and my. These are the biaxial moments. Okay, have you written this? Okay.
Yes.
So now step number 8. So what is step number 8? Step number 8, I think it is a selection of
Angle Purlin.
angle Purlin. Selection of angle Purlin. So here we have used the angle Purlin. So we can use I section Purlin, or we can use channel section Purlin, but we have used angle section. So we have to calculate first the width of angle. So width of angle. So width of angle is equal to L by 60. Correct? So L by 60. So L is what? L is the spacing of truss, correct?
Yes, sir.
So spacing is 4,000 because 4 meters is there. So 4,000 divided by 60. So how much it?
66.67.
66.67. So we can assume this is 70 mm. Okay, this is the requirement. The meaning of this, it should not be less than this. Here written, it should not be less than L by 60. It means greater than this one. Correct? So 70 mm. Then second, depth of angle. So depth of angle is equal to L by 45. So L is L by 45. L is again 4,000 divided by 45.
88.89.
88.
L by 40 आहे सर.
L by 40 का L by 45? L by 45 असेल.
L by 45 आहे सर.
L by 45. Please correct L by 45. So this is very IMP step for the MCQ examination. So we assume 90. So we can see the unequal angle section 90 by 70 like this. Okay, or more than this. So depth of angle is a 90 or more than this, and width of angle is a 70 or more than this. So now you can see the section in IS code. So in IS code the section is available. I will tell you here. Select ISA 100 by 75 by 6 at weight 8 kg per meter. Here area is not required. Here only two dimensions are required. The first dimension is depth of angle and second dimension is width of angle. So depth of angle, the minimum depth of angle is required 90 mm and maximum width required is 70 mm. So actually 90 by 70 section is not available in IS code, steel table. 90 by 70 section is not available in CS steel table. So 90 by 60 is available, but 60 is not a limiting width. So we can take this 100. 100 is a depth Instead of 70, we have taken here 75 by 6 mm at 8 kg per meter. Got it? How to select this section? Okay. So then next step number 9. What is step number 9? I think classify the section. Classify the section. Okay. So classification for flange. Classify the section for flange. So for flange, I think BF by TF is equal to. So now we have to take the BF by TF. This formula for, I think this formula for I section or channel section, correct? For angle section, which is the formula? For angle section, I have given two formulas for angle and for I or channel. For angle, how to calculate? I think D by T I have given, no? There is no flange, only here no flange, only for I section, angle section we have to take D by T. Correct? Is this correct? Have you? I have given this. Please speak. Is this given by me? No one is
No, sir.
responding.
Direct formula of BF by DF is given.
Actually, this is for BF by TF. This is for only I section or channel section. So for angle section, you can write for angle section D by T. For angle section D by T is the classification of section. So D by T, you have to use. So D is 100 divided by T is 6. So same D by T. D by T less than 9.4. Then D by T less than 10. Then D by T less than 10.5 and D by T greater than 15. Sorry, less than 15. So like this we have to take. Please correct this in procedure also. So this is plastic. So how much this value?
16.67.
15 point
16.67.
16.67. Okay. 16.67. It means, which is the classification? Slender. Good. Slender classification. So less than 9.4 plastic classification. In between 9.4 to 10.5, it is a compact classification. 9.4 to 10.5 compact. Less than 9.4 plastic. Then 10 point greater than 10.5 up to 15 is a semi compact, and greater than 15 it is a slender. So this comes in this category, greater than slender. So this is the classification. This is for angle section we have taken. So D by T. Okay. So this is the classification. Then next step number 10. or anything we have to calculate in this particular step?
For web.
So sorry, for web. Now here web is not given, not there, but you can calculate actually this is the your I section or this is channel section. So flange and web is there for I section and channel section. So here only we can take for d by 2. Okay, for angle section only we can take d by 2 because depth is critical here. Web is not critical. Whatever load is coming on this particular, if this is the your, this is the your, so this is the depth. So depth is critical. So here not required to calculate the wave because wave is not there. Only depth is there. So for angle only this we have to calculate. After that, after that what we have to calculate?
Find suitable angle section.
Okay, is this step number 10 or next step?
Step number 10.
Step number 10. Actually, suitable angle section we have find here only. Find the properties. Here we will write find the properties because angle section we have taken here and classification is taken here. So we have to require properties. We have to find out. Find the properties of angle section. Okay, so what properties we have to require? So this angle section we have selected 100 by 75 by 6. So we require Ixx. So go to steel table. We require Iyy value. Then we require ZE value. ZE means we can calculate by only required here Cyy value. So these three value we require. So go to steel table for the ISA 100 by 75 by 6. You can find these properties Ixx, Iyy, and Cyy. Are you able to see this section? Sorry, see this page?
Yes, sir.
Yes, sir.
Okay, so now here we have taken the section. Which section we have taken here? This section. Correct? Whatever I have marked underline, so this section we have taken. Okay, so for this we have to take Ixx value, Iyy value, and Cyy value. Got it? Actually, here Cyy in this direction is Cxx. Here we require the Cxx. If we see, actually this is the our depth and this is the Cxx value here. because we have to put this section like this. म्हणजे डेप्थ जास्त आहे अशा बाजूला आपल्याला प्रोव्हाइड करायचं आहे आणि दिस इज दी CYY. So it means we have to take CXX value. Please correct this CXX value. बघा ही हाईट आपली CXX आहे आणि ही हाईट आहे ती D आहे. आर यू गेटिंग? सो D मायनस CXX करायचं आपल्याला, तर मग CXX ची व्हॅल्यू लागते. प्लीज change this formula in procedure also. CXX put instead of CYY, put CXX. Everyone, you are getting? So what is how much IXX value? IXX is 100.9 into 10 raised to 4 mm raised to 4. IYY value is 48.7 into 10 raised to 4 mm raised to 4. And CXX value is for ISA. This 100 by 75 by 6 is how much? CXX value 30.1. So these three values we require. These are the properties of the angle section. Okay, so instead of CYY, we have to take CXX here. Write down this value IXX, IYY, and CXX. Have you written this?
Yes, sir.
Okay, so after you are writing, tell me, because it will be erased by me. 100.9 okay, so 100.9 into 10 raised to 4 mm raised to 4, then this is 48.7 into 10 raised to 4, and this is CXX. Please take here, correct this CXX. CXX is 30.1 mm. So in formula also you have to correct. Okay, so these are the IXX, IYY, and CXX value. Okay, so now we have to calculate ZP. So ZP, how we can calculate? IXX divided by Y max. So IXX, how to calculate Y max? IXX divided by D minus CXX. Here CXX is required. So instead of CYY, put here CXX. Change this in formula also, procedure also. Okay, so 100.9 into 10 raised to 4 divided by D is a 100 minus 31.1. So how much ZP? Then we have to calculate ZE. So ZE is equal to again IXX divided by I minimum. So IXX, I minimum will be the CXX. So 100.9 into 10 raised to 4 divided by CXX is a 30.1. So how much this values ZP and ZE? Please do the calculations.
Value of ZP is 14,434.90.
Okay, 1443.90, and ZE will be
Sir, 14 is remaining in ZP answer.
14
Is remaining in the ZP's answer. 14,434.90.
144 3 times 4.
4.
3 times 4, no?
Yes, 14,434.
14434.93.
Yes.
So now calculate ZE, elastic section modulus and plastic section modulus. So this required while calculating the moment of resistance in next step. So do the calculation and tell me answer.
Three 33,521.59.
33,521.59.
159.
Okay. So we got the values of ZP and ZE from this selected section. ISA 100/75/6. Okay. So then go to the next step, step number 11. So what we have to calculate in step number 11? So we have to calculate the design bending moment. So calculate design bending moment along the x-axis and y-y axis. Along the x-axis and y-y axis. Okay, for design bending moment for angle section. So MDX, design bending moment, MDX, in x is nothing but in x direction and y is nothing but y direction. So MDX is, what is the formula? What is the formula for MDX?
Beta B into ZP.
Beta B into ZP
into Fy upon gamma m naught.
Gamma m naught. Okay, so what is the value of beta B? So in the chapter of beam we have seen the beta B value is equal to 1 when the section is plastic and compact. So we have to use the value of beta B. How much value we have to use now? So this MDX should be greater than MX. Can you go in the chapter number 6 where we have used this beta B formula? So there I have written the formula. This beta B value is for 1 and again next value for slender classification. For slender classification, what is the value of beta B? Anyone can search in the chapter 6 example. After the classification stage we have calculated MD there also. So that MD or MX moment we have calculated. Shear force and bending moment steps we have seen. So there beta B formula was there. So are you getting? Who is searching?
सिलेंडर साठी दिले नाही सर.
मग कोणता फॉर्म्युला आहे?
इक्वल टू MDR इक्वल टू ZE अवेलेबल FY बाय गॅमा m नॉट दिले.
MD is equal to ZE available into काय म्हटलंय?
ZE अवेलेबल into FY अपॉन गॅमा m नॉट.
फोन गॅमा m नॉट हे कशासाठी दिलेलं आहे?
सिलेंडर साठी.
So this is given for slender. So here we have used just a minute, beta b. So what is the formula for MDY? I think 1.2 into ZE into Fy divided by gamma m naught. Is this formula for MDY?
Yes, sir.
So you can use here this formula. Instead of this MDX beta B फॉर्म्युला आपण या ठिकाणी वापरू शकत नाही. ZP येतच नाहीये. स्लेंडर सेक्शन आहे म्हणजे प्लास्टिक तो मोमेंट तुमचा प्लास्टिक झोन मध्ये जातच नाहीये. आर यू गेटिंग? If the classification we got the slender, so then this section is not going into the plastic zone. It means we have the MDX or MDY. It will be here. We have to use ZD value, not we can use the ZP value. So see, I will erase this. So here you can use ZD into Fy. So ZD is how much? 3352.59 into Fy is 250 divided by gamma m naught is 1.1. 1.1. So how much this value? Please correct this formula. So how much this calculation?
7.618 into 10 raised to 6.
How much? How much? 10?
7.618
618 into 10 raised
into
to
10
6.
raised to 6.
6 Newton mm. Okay, so what is our mx value?
One 1195.93 Newton mm.
One
95.93.
So it means 1.1. Tell me. 1.1.
Sir, 1195.93 Newton meter आहे.
असू दे की मला 1 पॉइंट मध्ये सांगा किती 3 डिजिट मायनस करा की
1.195.
1.195 into 10 raised to 3 Newton मीटर. न्यूटन मीटर आहे ना तुमचा?
हा
Yes, sir.
एक मिनिट. मग हे काय येणार आहे? इंटू 10 raised to 3 तर येणार आहे. हे न्यूटन मीटर झालं. करेक्ट? नाव हियर in this, here I will write in Newton meter. 10 raised to 3 Newton meter, correct? See whatever
Yes, sir.
So now this value is 1.195 and this value is 7.6. It means this is greater. Are you getting?
Yes.
Okay. So similarly, use next formula. MDY, calculate MDY. So MDY is a 1.2 into ZE. Again 33521. 33521.59. into again 250 divided by 1.1. So how much this value? This should be greater than my. So my is 3295.93. 3295 point. So what is the value of MDY?
9.142 into 10 raised to 6 Newton mm.
9 point, once again.
9.142 into 10 raised to 6 Newton mm.
142 into 10 raised to 6 Newton.
Mm.
So 10 raised to 3 Newton
Meter.
correct? 10 raised to 3 Newton meter. So it is again greater than this. So hence safe, whatever movement we have calculated in x direction and y direction, design bending moment in x direction and y direction are greater than the your biaxial movements. Okay, so it means whatever section we have used for this section, ZE value we have taken, correct? ZE जी व्हॅल्यू आपण जी घेतली त्या ZE व्हॅल्यूवर जे mx आणि my जे काढले mdx आणि mdy, so these mdx and mdy are greater than the whatever bending moment coming for this particular section is a safe. Okay, it means whatever section we have provided 100 by 75 is a safe for as a Purlin. Got it? And now, so this is the mdx and mdy are the greater than the mx and my. So next step number 12, and this is the last step. So step number 12 is a check for biaxial bending. So why we are showing biaxial? Because the movement is coming both direction. It is in x direction and it is y direction. So both direction movement is coming on the Purlin. So the biaxial movement we are taking. Why biaxial? Because the sheet is in both direction. This is the Purlin. ह्या पर्लिन वरती दोन्ही डायरेक्शन वर तुमची मूवमेंट येते. So we have to calculate this biaxial movement mx and my due to this dead load, live load and wind load. Three loads here coming, and both loads, the loads are coming in both direction, mx and my direction. So what is the check for the biaxial bending? It means mx divided by mdx plus my divided by mdy. It should be less than 1. So mx, is a 1.195, correct? 195 into 10 raised to 3. Similarly, mdx is 7.618. 7.618 into 10 raised to 3 plus my is a 9. My is a 3.295 into 10 raised to 3, and mdy is a 9.142 into 10 raised to 3. Okay, so now this value should be less than 1. So do the calculations and tell me the
0.528.
0.528. It means it is less than 1. So whatever section we have provided is a safe for whatever dead load, live load, and wind load coming on the roof truss. So dead load is given 150 Newton per meter. Live load was given 350 Newton per meter in problem statement, and wind load also given 750. So for these three types of load, whatever purlin we have provided, that purlin ISA 100 by 75 by 6, that is safe for both the movements. That movements are MDX or MDY. These are the design movements. Got it? In this way, we can design the purlin. Got it, everyone? Design means what? We have to provide the section for the given load. जो काही लोड येणार आहे त्या लोड साठी एक सेक्शन सिलेक्ट करणं, that is the first stage, and either this section is safe for the given load, that we have to calculate. So here movement we have to calculate, that movements are carried by this particular section safely. So this is the design of purlin. Got it, everyone?
Yes, sir.
Okay, so this is the design of purlin in this way. So
Sir.
this is the yeah.
ZP ची व्हॅल्यू आपण कुठे यूज करायची सर?
झेडपी ची व्हॅल्यू ऍक्च्युली आय सेक्शन आणि चॅनल सेक्शन मध्ये लागते, इथं नाही लागत. आपण प्रोसिजर लिहिली, प्रोसिजर मध्ये झेडपी ची व्हॅल्यू आता या ठिकाणी जर प्लास्टिक सेक्शन आला असता, सी हिअर, if classification comes plastic, then what formula we have to use at that time? Beta B into ZP we have to use.
Yes, sir. Yes.
Into Fy divided by gamma. This formula we have to use. Please write down in procedure. This formula we have to use if plastic or compact classification is there. So same formula we have to use in the beam also. Are you getting? This formula also we have to use in beam for plastic and compact. And ZE into Fy divided by gamma m naught. This formula is for slender. Is this available in this beam chapter also?
Yes, sir.
So purlin is nothing but one of the beam. कारण का ज्याच्यावरती तुमचा युनिफॉर्मली डिस्ट्रीब्युटेड लोड येतोय, हा फ्लेक्झरल मुवमेंट मेंबर म्हणून ऍक्ट होतो, म्हणजे याच्यावरती बेंडिंग मुवमेंट येत असते. सो दिस इज ऑल कॅल्क्युलेशन रिलेटेड टू बेंडिंग मुवमेंट. सो पर्लिन इज अ फ्लेक्झरल मेंबर and beam is also flexural member, so which carries the moments. मग हा फॉर्म्युला प्रोसिजर मध्ये करेक्शन करण्यासला करा. So this formula is for plastic and compact, and this second formula is for slender. So this formula we have used now because our section classification is a slender. प्लास्टिक म्हणजे ज्यावेळी प्लास्टिक झोन मध्ये सेक्शन गेला त्याच वेळी झेडपी आपल्याला लागतोय. इलास्टिक झोन मध्ये सेक्शन असेल त्यावेळी झेडी लागतो. Are you getting? Plastic section modulus and elastic section modulus, when we are getting compact आणि plastic section ज्यावेळी आहे त्यावेळी झेडपी ची व्हॅल्यू लागते. मग आता हा फॉर्म्युला आपण वापरलाच नाही बिकॉज द सेक्शन क्लासिफिकेशन इज स्लेंडर. So if the slender classification is there, then we have to use the ZD. So we have used this formula. Got it? Okay, so in this way, here end of the chapter number 7. So the remaining is the one.
डायग्राम काढायला सांगितले, नीट स्केच.
नीट स्केच काढायला सांगितलं. बरं, नीट स्केच. ओके, so where to calculate need sketch? Here we have to calculate. So we have decided the section where 100 by 75 by 6. It means we have to, if this is the your principal rafter, so we can provide the section like this. So this is your AC sheet or GI sheet. So this, in this way we have to draw the sketch, and this way so this is your ISA 100 by 75 by 6. So this is your principal rafter PR. This is AC or GI seat, and this will be the angle. मग या ठिकाणी तुमचा हा होता तो CYY होता, sorry CXX. So this is the sketch we have to draw. It means on the principal rafter, the purlin is rested. On the purlin, seats will be there. So that seats and purlin, the seats are connected with the purlin by this hook. So how we have to place this purlin? So purlin we have to space like this. Generally, along the depth is a vertical we have to keep here. ही जी डेप्थ आहे आपण वर्टिकली प्लेस केले. So depth is 100, width is 75. So this is the sketch. You can draw the sketch. Sketch is nothing but whatever section we have used, that section you have to draw, and you have to give their dimensions and properties. If you have to calculate this sketch in bolted connection, that you have to show the bolt. Then somewhat we have drawn in this bolted connection, welded connection, tension member, compression member. It means the plate and section we have to use by bolted connection or welded connection. So such drawings, whatever we have designed, that drawings we have to draw by this sketch. And that is the role of the here civil engineer. Why? So as per design, we have to draw the drawings, and as per the drawings on the site, the construction engineer will construct this particular structure by using whatever drawing you have given. So here you have given now purlin size, you have given ISA 100 by 75 by 6. So then that construction engineer on site, he will do? He will take this section for the length whichever mentioned in the drawing, because the hall dimension is known, industrial shed. So width and length is known. So this length he will calculate, and this section he will take from the market or purchase. He will mark from the market, and he will provide this angle purlin of this side. So for dimension purpose, we have to draw the drawing. Or how you have provided this, because you can provide like this also. म्हणजे लेंथ जास्त, this is the width and this is the depth, म्हणजे ही बाजू 100 mm, ही बाजू 75, असंही प्रोव्हाइड करू शकता. बट असं प्रोव्हाइड करायचं असेल तर तुम्हाला CXX ची व्हॅल्यू जिथे घेतली त्या ठिकाणी CYY ची व्हॅल्यू घ्यावी लागेल. while calculation of ZP and ZE, ZP ची आणि ZE ची व्हॅल्यू जिथे तुम्ही कॅल्क्युलेट केली, त्या ठिकाणी तुम्ही जिथं CXX घेतला त्या ठिकाणी CYY ची व्हॅल्यू घ्यावी लागेल. जर ही 75 आणि ही 100 वापरली तर. आर यू गेटिंग? So as per your calculation, the drawing and design will change. ही वर्टिकल डेप्थ ठेवली म्हणून CXX वापरला आपण. येते का लक्षात? जर ही वर्टिकल डेप्थ जर हॉरिझॉन्टल केली या ठिकाणी, तर तुम्हाला काय वापरावे लागेल? तर CYY ची व्हॅल्यू you have to use while calculating the ZP and Z. Got it?
Yes, sir.
This is very important here. Because of your orientation of your section, CX and CY ची व्हॅल्यू चेंज होऊ शकते की नाही? तुमचं कसा सेक्शन तुम्ही ओरिएंट करताय त्याच्यावरती. Here you have oriented your section along the depth. बरोबर आहे की नाही? मग या केस मध्ये CXX व्हॅल्यू ही आहे. जर तुम्ही हॉरिझॉन्टलला जर डेप्थ प्रोव्हाइड केली आणि व्हर्टिकलला विड्थ प्रोव्हाइड केली, तर तुमचा CXX चेंज होणार की नाही? CXX च्या ऐवजी CYY ची व्हॅल्यू येणार ZP च्या कॅल्क्युलेशन मध्ये. सी द ZP and ZE calculation. where we have calculated ZP and ZD calculation? Here. So D minus CXX. So this is the CXX and this is the D. So D minus CXX we have taken. If we place like this, so now this is CXX, this will be the CYY. So now your depth will be this. So D minus CYY you have to take here. Are you getting? कारण का movement कोणत्या डायरेक्शनला आहे हे खूप इम्पॉर्टंट आहे. Okay, so in this way we will end of this unit and unit number 7. Now unit number 8 is remaining, that is the column base. It means foundation way for the building. Industrial shed ला जे foundation आहे ते foundation design करायचं आहे. So there are two types of examples are there, design of slab base and design of gusseted base. So only maybe 4 hours are required. Two example we will see in this particular chapter in the design of column base, and I will show you by sketch how the column base will look, and we will design one example based on the design of slab base, and one example is based on the design of gusseted base. So there are two types of base are there for the steel structure. So here end of unit number 7. So only one unit is remaining and 4 to 5 lectures are required. So tomorrow and up to Saturday we will cover. Are you getting? So wait, I will take attendance and we will close this lecture, because next lecture you have, I think, of next subject. I'm taking attendance here.